Welcome to the WWC Advanced Group Design Standards Training module focused on introducing the logic of regression discontinuity designs, or RDDs. If you have not done so already, please view the introduction module before viewing this module. The introduction module reviews important background information about this training and describes accompanying resources. You can access all the resources mentioned in this module through the WWC website, whatworks.ed.gov. This module presents an overview of RDDs and discusses approaches that commonly are used to estimate intervention impacts in these designs. This module describes how to assess whether a study is eligible for WWC review as a regression discontinuity design, and finally, this module discusses the possible WWC study ratings for these types of designs. After completing this module, you will be familiar with the general structure of RDDs and will be able to identify whether a study is eligible for WWC review under the RDD standards. Regression discontinuity designs are similar to randomized controlled trials in that the intervention and comparison groups being compared are formed by design rather than through self-selection, which is more typical in quasi-experimental designs. However, regression discontinuity designs are different from randomized controlled trials in that the intervention and comparison groups are not formed randomly. Instead, the intervention and comparison groups are formed purposefully. More specifically, regression discontinuity designs occur when interventions are offered based on whether the unit of assignment has a score above or below some cutoff value on a known variable. The variable used to assign units to the intervention or comparison group is commonly referred to as the forcing variable, but is also often referred to in the literature as the assignment or running variable. In regression discontinuity designs, the units that are assigned to intervention or comparison groups may be individuals, such as teachers or students, but they could also be clusters of individuals, such as whole classes or schools. For instance, in an individual assignment RDD study, students might be assigned to receive a supplemental summer tutoring intervention if they score below a cutoff value on a standardized test. Or, in a cluster assignment RDD study, schools might be awarded a grant if they score above a cutoff value on some application score. Thus, assigned units in an RDD could be individuals or clusters of individuals. The graph shown here visually displays an example of the assignment mechanism in a regression discontinuity design. In this example, let's say the intervention of interest is a remedial mathematics intervention used to provide additional instruction and support to middle school students who were struggling in math. Here, the forcing variable used to assign individuals to conditions was a math achievement test administered at baseline, and let's say the researchers selected a cutoff value of 50 on that forcing variable, meaning that any students who scored at or below 50 on the pretest assessment are assigned to receive the remedial mathematics intervention supports. And those students who score above 50 on the pretest assessment are assigned to the comparison group and thus receive business as usual services. So, in this example RDD study, the intervention would be offered to units based on whether they score above or below the cutoff value of 50 on the forcing variable or the baseline math assessment. It is worth reiterating that RDDs occur when interventions are offered to units based on whether they score above or below some cutoff value on a known forcing variable, depending on the nature of the intervention and the measurement features of the forcing variable. For instance, in the example shown here, those who score below the cutoff value would be assigned to receive the intervention because the intervention of interest was a remedial math intervention designed to improve mathematics achievement, and because the forcing variable was a baseline measure of math achievement where lower scores indicated lower achievement. However, in contrast, many other RDDs may be designed in such a way that units who score above the cutoff value are the ones assigned to receive the intervention. For example, a merit aid intervention for first-time college students might assign high-achieving students to receive a financial aid award to defray the cost of college. For any students who score above some cutoff value on an admission score that is comprised of their high school grade point average, class rank, and ACT test score. In that example, students scoring above some cutoff value on the forcing variable would be assigned to receive the merit aid intervention. Effects reported in RDD studies provide estimates of average impacts at the cutoff value of the forcing variable. The effect of an intervention typically is estimated in an RDD as the difference in mean outcomes between intervention and comparison group members at the cutoff, after statistically adjusting for the relationship between the outcome and forcing variable. A regression line or curve is typically estimated separately for the intervention group members on one side of the cutoff value and the comparison group members on the other side of the cutoff. The difference in these regression lines at the cutoff value of the forcing variable then serves as the estimate of the effect of the intervention. In other words, an intervention effect is said to have occurred if there is a discontinuity in the two regression lines at the cutoff value of the forcing variable. This effect estimate represents the average intervention effect for units right at the cutoff value of the forcing variable. RDDs will generally provide asymptotically unbiased estimates of the effect of an intervention if the outcome forcing variable relationship is modeled appropriately and if the forcing variable was not manipulated to influence assignment to the intervention group. Thus, as you will see in the remaining modules in this training series, these considerations play a central role in the WWC's standards for reviewing evidence of RDDs because appropriate statistical modeling is essential for unbiased impact estimation. One statistical approach for estimating intervention impacts in RDDs is to use a single regression model to estimate the discontinuity in the outcome at the cutoff value of the forcing variable. In this single regression model specification, Y is the outcome measured for unit I, X is the forcing variable centered at the cutoff value, T is indicatory or dummy variable for whether a unit was assigned to the intervention or comparison group, and epsilon is the error term. In this single regression model specification, the intervention impact on the outcome at the cutoff is represented with beta 2, or the coefficient for the treatment indicator in the model. Alternatively, the other common statistical approach for estimating intervention impacts in RDDs is to use two separate regression models, one for each side of the cutoff of the forcing variable. In the two regression model specification, Y is still the outcome measured for unit I, X is the forcing variable centered at the cutoff value, and epsilon is the error term. The superscripts R and L are then used to indicate whether the model was specified using the data from the right or the left side of the cutoff on the forcing variable, respectively. In this two regression model specification, the intervention impact on the outcome at the cutoff is represented by the difference between the beta zeros from the two regression models, or the intercept terms from those models. Because again, the forcing variable predictor x in the models has been centered around the cutoff value of the forcing variable. Given the critical importance of modeling specification to ensure unbiased impact estimation in RDDs, researchers often will restrict their analytic sample to units within a narrow range of the forcing variable values right around the cutoff, which is called the bandwidth. For example, in the graph shown here, the researchers may have estimated the intervention impact only using data within a bandwidth of 10 points around the cutoff value of 50. This means that the model or models used for impact estimation only would use data from intervention group participants with pretest scores ranging from 45 to 50, and comparison group participants with scores ranging from 50 to 55. The goal of using these types of local regression modeling approaches is to better ensure that the outcome forcing variable right at the cutoff is modeled appropriately. Rather than using local regression approaches for impact estimation in RDDs, researchers may instead choose to use all observed data in impact estimation models. This means that rather than estimating regression models locally within a bandwidth, the researchers instead estimate regression models globally using all available data. In this case, researchers typically use fit statistics to select a model specification that is the best fit to the observed data. When using global regression approaches for RDDs, researchers usually estimate polynomial regression models rather than linear regression models to reflect the most appropriate functional form of the outcome forcing variable relationship. So when researchers use global polynomial regression approaches in RDDs, their impact estimation models typically include additional polynomial terms for the forcing variable, such as squared or cubed terms. We can view a few graphs here to illustrate intervention impacts in RDDs. In this graph, let us again imagine we are planning to offer a remedial mathematics intervention for middle school students. A sample of middle school students complete a baseline mathematics achievement test. This pretest score will be used as a forcing or assignment variable for a regression discontinuity design with a cutoff value of 50. In other words, any students scoring below 50 on the pretest score will be assigned to the intervention group and will receive the remedial mathematics intervention, and any students scoring above 50 on the pretest score will be assigned to a business as usual comparison group. If we are interested in examining the impact of the intervention on follow-up mathematics test scores, then this regression discontinuity design can provide a consistent estimate of the local average impact right at the cutoff value of 50 on the pretest score if we estimate regression lines separately for the intervention and comparison groups on either side of the cutoff. Thus, our goal would be to assess whether there is a discontinuity in the two regression lines at the cutoff. For instance, in the graph shown here, if we use the two regression model specification approach, we might estimate a best fit regression line for the intervention group participants on the left side of the cutoff and a best fit regression line for the comparison group participants on the right side of the cutoff. Then the discontinuity between those regression lines at the cutoff value of 50 represents the intervention impact estimate of interest. In the example shown here, the intervention has shown a positive impact given that the intervention group participants have higher mathematics follow-up test scores than the comparison group participants, right around the cutoff value of 50 on the forcing variable. However, let's say the intervention has no impact on students' mathematics scores at follow-up. In this scenario, we might observe a pattern of data like those shown here, where there is no discontinuity or no jump in the best fit regression lines right at the cutoff value. The previous graphical examples assume that the best fit regression lines were linear regression models. However, remember that researchers often fit polynomial regressions to ensure that nonlinearities in the outcome forcing variable relationship are appropriately modeled. In the example shown here, the researchers may have estimated polynomial regressions on either side of the cutoff, but still found no evidence of an impact or no evidence of a discontinuity in the best fit regression lines right at the cutoff value of the forcing variable. Once again, it is common for researchers using an RDD to estimate only best fit regression lines on either side of the cutoff value using a subset of forcing variable values that fall inside of a specified range, namely the bandwidth. This graph shows an example where the researchers may have estimated local linear regressions within a bandwidth, but still found no evidence of an intervention impact right at the cutoff value of the forcing variable. Now that you are familiar with the general approach used in RDDs, it is time to discuss the WWC's eligibility requirements for reviewing evidence from studies using these types of designs. The eligibility criteria for WWC review of RDDs are the same as those used for group design studies. Namely, RDDs must be publicly available and released within the 20 years preceding their review, use eligible populations, examine eligible interventions and eligible outcomes, and be free of confounds. In addition, to be reviewed as an RDD, a study must meet 3 additional criteria pertaining to the forcing variable. The first requirement is that the intervention assignments must be based on a numerical forcing variable that has a unique ordering of values from low to high, such that units with forcing variable scores on one side of the cutoff are assigned to the intervention group and those on the other side of the cutoff are assigned to the comparison group. For example, numerical values on test scores would meet this requirement. Conversely, race, gender, first letter of the last name, or binary variables never would meet this requirement because they are not numerical forcing variables with a unique ordering of values from low to high. In some instances, RDD studies may use multiple forcing variables or multiple cutoffs to assign participants to conditions. Studies that use multiple forcing variables or cutoffs with the same sample are eligible for review under RDD standards only if they use a method described in the literature for reducing those variables to a single forcing variable, or if they analyze each forcing variable separately. As with randomized controlled trial designs, non-compliance with treatment assignment is permitted within RDDs. The second unique eligibility requirement is that the forcing variable must include at least 4 unique values below the cutoff and at least 4 unique values above the cutoff. This is required to ensure that the outcome forcing variable relationship can be credibly modeled. For example, a 5-category proficiency variable that range from 1 to 5 may be numeric with a clear ordering of values, but it would not have enough unique values to satisfy this requirement. Similarly, student letter grades of A, B, C, D, and F could be converted to a numeric scale ranging from 1 to 5, but would not have enough unique values to satisfy this requirement. The third and final eligibility requirement for reviewing a study under the WWC's RDD standards is that the forcing variable used to calculate impacts must be the actual forcing variable and cannot be a proxy or estimated forcing variable. The WWC defines a proxy forcing variable as one that has a correlation of less than 1 with the actual forcing variable. Researchers commonly attempt to create proxies for interesting interventions when they do not have access to the true forcing variable. Careful attention must be paid when reviewing studies to ensure that the true forcing variable was used in the model. If a study claims to be based on an RDD but does not meet the 3 eligibility requirements, then the study is not eligible for review under the RDD standards. Time for your first knowledge check in this module. A study assessed the effects of a mathematics tutoring intervention for students in the 6th grade. Students who receive a letter grade of D or F in their 5th grade mathematics course were assigned to receive tutoring. Students who receive a letter grade of A, B, or C were assigned to the comparison group. Is this study eligible for review as a regression discontinuity design under the Regression Discontinuity Design Standards? Your choices are A, yes, B, no. You may want to pause this video now to think about your answer. The correct answer is B. To be eligible for review as a regression discontinuity design study under the RDD standards, units must be assigned to conditions using a numerical forcing variable that includes at least 4 unique values both above and below the cutoff. A 5-category letter grade does not have at least 4 unique values on both sides of the cutoff. Therefore, this study would not be eligible for review as a regression discontinuity design under the WWC's RDD standards. It is important to remember the concept we discussed earlier, namely that assigning students to conditions according to a letter grade could be acceptable as a numeric forcing variable if it is represented by a number in the analysis and the forcing variable has 4 unique values above and below the cutoff. But in this example, the forcing variable of letter grade did not have at least 4 unique values on both sides of the cutoff. Knowledge Check 2. Students were assigned to a reading intervention based on their composite scores on a math achievement test and a teacher assessment of student need. These were combined to create a within-school ranking that was used to assign students to conditions. The authors did not have access to the composite scores or teacher assessments, but did have access to all subscores and knew which students were in the intervention and comparison groups. To conduct their RDD impact analysis, the authors used composite estimates from a logistic regression that provided perfect prediction of treatment status as the forcing variable. Is this study eligible for review as an RDD? Your choices are A, yes, B, no. You may want to pause the video now to think about your answer. The correct answer is B. To be eligible for review as a regression discontinuity design under the WWC's RDD standards, the forcing variable used to calculate impacts must be at the actual forcing variable used to assign students to the intervention. The authors did not have access to the actual forcing variable, namely the composite reading achievement test score used to assign students to the intervention or comparison conditions, but rather only had access to a proxy forcing variable, which was constructed as a weighted average of subscores. Therefore, this study would not be eligible for review under the WWC's RDD standards. After a study is determined to be eligible for review as an RDD under the WWC standards, the findings from the study can receive one of 3 possible ratings: meets WWC standards without reservations, meets WWC standards with reservations, or does not meet WWC standards. Standards 1 through 4 apply to all types of RDDs, including sharp and fuzzy RDDs, where fuzzy RDDs are those where some units do not participate and the condition to which they were assigned. Standard 5 only applies to fuzzy RDDs under certain circumstances, which is discussed in the fuzzy RDD training module in this series. To receive the highest possible rating of meets WWC standards without reservations, the study findings must completely satisfy the 5 RDD standards shown in the table displayed here. The next 5 modules in this training series will describe each of the 5 RDD standards in more detail. To receive the rating of meets WWC standards with reservations, the study findings must partially satisfy each of the 5 RDD standards shown in the table displayed here. Note that if the findings from an RDD study fail to satisfy at least partially the 5 RDD standards, review teams have an option of reviewing findings under QED standards. This option is not available for fuzzy RDDs, however. And finally, findings from an RDD study will receive the rating of does not meet WWC standards if they fail to at least partially satisfy the RDD standards, or if they fail to satisfy QED standards when review team leadership decides to pursue the QED route. As with RCTs and QEDs, RDDs also must meet the WWC outcome measure standards and be free of confounds. Like RCTs, RDDs may assign participants to conditions at the individual or cluster level. Findings from cluster assignment RDDs are eligible for the research rating meets WWC standards without reservations if the findings completely satisfy all 5 RDD standards using individual level or cluster level data. Findings from cluster assignment RDDs are eligible for the research rating meets WWC standards with reservations if the findings partially satisfy sufficient RDD standards using individual level or cluster level data. Throughout the remaining modules in this training series, we will highlight when any special considerations are needed in the application of the RDD standards to cluster assignment RDDs. Finally, it is worth noting that many RDD studies will report multiple impact estimates of interest, for example, for multiple outcomes of interest or multiple subgroups of interest. In these scenarios, each of the 5 RDD standards covered in subsequent modules will be applied to each outcome subgroup combination, resulting in a separate rating for each combination. The overall rating for a study then will be the highest rating attained by any outcome subgroup combination that constitutes a main finding. This is identical to how the WWC assigns ratings for randomized controlled trials and quasi-experimental designs. Usually only the full sample will be a main finding, but sometimes reviews will focus on a subgroup of interest, such as students with autism or students with disabilities. Throughout the remaining modules in this training series, we will highlight when any special considerations are needed in the application of the RDD standards to studies that report multiple impact estimates. This concludes our module on regression discontinuity designs. Let's review what we discussed in this module. We described the general structure and assignment mechanism in RDDs. We discussed common approaches to impact estimation in RDDs reported in the educational research literature. And finally, we described the criteria used to assess whether a study is eligible for review as a regression discontinuity design under the RDD standards. The next module in this training series will focus on the WWC's first RDD standard, the integrity standard, which outlines requirements for establishing the integrity of the forcing variable used in the design.